how we graph. Analyzing graphs of polynomial functions. This should be a good time. Hope you're going to enjoy 5-4. Analyzing graphs of polynomial functions. This is how we graph. Alright. Well, welcome to 5-4. I hope you have your graphing calculator handy. If you don't, you might hate your life. So, just kidding. You wouldn't hate it. It just wouldn't be as much fun. So when we have graphs of polynomial functions, what we're going to have to do is make a table of values to find several points, connect them with a smooth, continuous curve. So this won't be like a discrete curve. However, we're going to have multiple points, so not just 3 or 5. You may have up to like 7 points. Knowing your end behavior from 5-3 will help you complete your graph. So let's look at our first example here. We need to graph this function by making a table of values. Now, it's nice to know by looking at your first term here. This is a degree of 3. So we have an odd degree polynomial, which means your graph is either going to be going up and coming back down, or from left to right, or it's going to be going down, continually going down from left to right. So the way we can have an idea of what our graph is going to look like is to look at your initial, or at your leading coefficient. So since that is negative, that means our line is going to be going down from left to right. So we're going to have this type of graph. So we know it's going to look something like this. So here's your end behaviors. Now we need to find some points that are in between here to put into our table. What we're going to do, we're going to make this much easier on you, is we're going to actually go to your graphing calculator and we're going to type this equation into your calculator. So in order to graph this function, what we're going to do is we're going to have to go to your y equals button, and we're going to type in your equation. So we're going to say we have a negative x, which is up here by your green key, to the third power. Now in order to go to the third power, you hit your caret key, type the number 3, and then make sure you cursor right out of it so that you have a big blinking box here now. You're not just typing up here still. Then we have minus 4x squared. Notice when you type in a square, it automatically kicks you over to the right. Plus 5. So we hit enter, and then you're going to hit your graph key, which is up on the top right. So you hit graph. Here is your lovely graph. Now it would be really nice if we just plot this straight down, but unfortunately some of you don't plot very well. In the past, what we have done is we have just chosen values starting like at -3, -2, -1, 0, 1, 2, and 3. Only problem is that doesn't show all your graph, because if you start where x is -3, well, x is -3 is right down here. You'd have a graph that doesn't necessarily go back up. You would just have this little part of your function right here. So we know that our graph, with our end behaviors, we need to have something over here at least at -4. So what we're going to do is we're going to use our table feature. So we're going to hit second and then your graph button, because right here in the blue it says table. So if you go to your table, then what we're going to do is we want our first x value to actually be a -4. So if we go back to our graph, notice how -4 will give us another point coming up. So we're going to go second table, and you need to just go cursor up until you get to a -4. So these are the values that you're actually going to use on your table. So we're going to go back to our notes here, and we're going to start at -4 instead. So I need to get rid of all these here, and we're going to go from -4, -3. We're going to try to use 7 points here, and hopefully that will include everything. So 4, 5, 6, 7. So if we type these in, then according to your -4, what you would have is a 5 in for your value. So we're going to say we have a 5 right here. And then for x equals -3, we get a -4. And then at -2, we have -3. For -1, we have a 2. We have a 5. 1, we have a 0. And 2, we have a -19. So we know this is going to continue going down. So let's plot these points. So we're going to go here to back 4, up 5. Here's a dot. So we know our end behavior is going up from here. We're going to back 3, down 4 is right here. Back 2, down 3 is right here. Back 1, up 2, actually, sorry, here we go up here. And then 0, 5 is continually going up. Then we go over to 1, 0, and 2, negative 19. Well, that's going to be way down here. So what we do when we connect these points is we're going to draw our graph down here. It's going to touch down here and then come back up. Continues going up here to the 5. Oh gosh, that's not very good. Down through 1, 0, and since 2, negative 19 is way down, way down there, so we're going to continue going down. Don't cross over where x equals 2. So it looks like our end behaviors were correct. We're going to erase those. But this is your function. So notice if you have a degree of 3, you actually have 2 curves. Those 2 curves will actually have some significance here in one of our later examples. So that's how you can use your table feature of your calculus.